Hi, this is Martin Lindsay from the Studying Learning Centre at RMIT University. This is a short movie on factorisation, the difference of two squares, or dots. Let's first of all review our knowledge of removing brackets, x plus 5, x minus 5 in this example. And if you go down 3 lines, we end up with an answer of x squared minus 25. Notice that is the same as x squared minus 5 squared. In other words, what we have here is terms in brackets differ only in the sign in each bracket on the left hand side, and the expansion on the right hand side is the difference of two terms, both of which are perfect squares, x squared and 5 squared. So in general we can state that the dots rule says a plus b times a minus b is the same as a squared minus b squared. So the terms in brackets on the left hand side differ only in the sign, plus or minus, in each bracket, and the expansion on the right hand side is the difference of two terms, both of which are perfect squares. Let's look at an example. Here we have x squared minus 36. And the first thing to do is to see if both these terms are perfect squares. Well, they are, because x squared is the same as x times x squared, and 36 the same as 6 times 6, which is 36. So we can now go on and state the rule, which says that x squared minus 36 is the same as x plus 6, x minus 6. The only difference is the sign in each brackets. Let's look at another one. 4a squared minus y squared. The first question, are each of the terms perfect squares? Well, they are. 4a squared is the same as 2a all squared, or 2a times 2a, and y squared is the same as y times y. So the expression is the difference of two squared, or dots. So we can use the rule, which says that 4a squared minus y squared is the same as 2a minus y, 2a plus y. The only difference is the sign in each brackets. Now let's look at a slightly more difficult question. We have 3x squared minus 48. So the first question is the expression a dots? Well, it's not, because neither of those terms are perfect squares. However, when we factorize this expression by taking 3 out of the brackets, we have 3 brackets x squared minus 16. But notice this time that x squared minus 16 is a perfect square. X times x, and 16 is 4 times 4. In other words, 3x squared minus 48 is 3. Open up big sets of brackets in blue. Then we have x squared in red, minus 4 squared in red, which gives us 3 brackets x plus 4, x minus 4. Now, in this final example, we have x plus 2 all squared minus 9. First question is, are these two terms perfect squares? Well, the first term must be, because it's x plus 2 all squared, so that is, 9 is a perfect square because 9 is 3 times 3. So we now have the expression x plus 2 all squared minus 3 all squared. In the rule, that gives us x plus 2 plus 3. Notice the blue plus, minus x plus 2 minus 3. Notice the blue minus, which simplifies to x plus 5, brackets, x minus 1. And that's our answer. Now try some problems for yourself. The answers to these questions are on the next slide. Thanks for watching this short movie.